Hi everyone. Today we're going to be talking about the zeros from graphing using the calculator and vertical motion. So we're going to be talking about zeros of a function or of a quadratic function. And yesterday in class we learned how to solve a quadratic equation to find the zeros. Remember, we also called those zeros the X intercepts of the graph. We called them the solutions to the function. We called them the roots of the function. So essentially we're finding the same thing. We're setting the equations equal to 0 and solving by factoring. But right now what I want us to look at is when we're looking at real world examples. The most common use of a quadratic function is in vertical motion problems. So today we're going to look at the real world application of this. So we're going to be looking at vertical motion. Okay. So in order to do vertical motion problems, we're going to have to work with a model. And there is a model when we're dealing with feet and seconds. The model is this formula, h at t, so a height at t time, is equal to negative 16t squared plus v sub 0 t plus h sub 0. So let's just identify that. Negative 16 takes into the gravity. It's never going to change. We're going to just be plugging things into this actual model. V sub 0 means the initial velocity, so speed. Okay, so I want you to think of the velocity for now as the speed. Okay, and the initial velocity means the starting speed. And then h sub 0 just means the initial height of wherever you could be standing or throwing something. So h sub 0 just means where the starting height. Okay, so starting height. So if the starting height, we say, is on the ground, for example, it starts on the ground, then the initial height will actually disappear and it will become 0 because on the ground means 0. Initial velocity or speed, it means how hard you kick, throw, or shoot an object or how fast it's moving, okay? All right, so let's look at an example. You have a soccer ball. It's kicked from the ground level. So that's my starting height with an initial velocity of 32 feet per second. Okay, oops, sorry guys. After how many seconds will the ball hit the ground? All right, so first we have to write the general projectile function because that's what it's called. It's called a projectile function. So the general function is, and I want you writing it so you practice it, is h at t equals negative 16t squared plus v sub 0 t plus h sub 0. Okay, now we're going to plug in what we know. Plug in anything you can find. Okay, so what can we find? We found our initial height because it's on the ground level, so h sub 0 is equal to 0. And our initial velocity is 32 feet a second, so v sub 0 is 32. So we plug both of those into our function. So h sub t equals negative 16t squared plus 32t. And that h sub 0 goes to 0, so that's our equation. All right, so then it asks me, after how many seconds will the ball hit the ground? So let's think about that as a picture for a second. All right, so I kick the ball, it goes up in the air, it gets to its highest point, it comes down and it hits the ground. So if I said what was the highest point, well then you guys would know we'd be looking for the vertex. Okay, but when does the ball hit the ground? What is it actually? Is that where it hits the ground? If it goes up and it comes back down, that's the point where it hits the ground, okay? That means I'm trying to find the X intercept or the solutions or the zeros of the function. So how do we do that? So we set your equation equal to 0 and solve for t. So negative 16t squared plus 32t equals 0. Okay, so now what do? Well, I first want to see if I can simplify it, and I notice that 16 and 32, I can divide each term by 16 to simplify the equation. I'm actually going to divide by negative 16 so that my t squared is positive. All right, so I'm going to divide by negative 16, and I'm going to get t squared minus, oops, let me fix that, minus 2t equals 0. Okay, so now I have to solve by factoring. Now this is one of those special cases. Remember, first step we always do is we take out our GCF. So I'm going to take out a t, and I'll be left with t minus 2 equals 0. All right, so then we set each piece equal to 0. So t equals 0, t minus 2 equals 0, and so I add 2 on both sides and I get t equals 2. So that's telling me that this ball is on the ground at a time of 0 seconds and a time of 2 seconds. So here's the 0 seconds and here's the 2 seconds. So my answer would be 2 seconds. On these questions, the most important part for you is really just to think about what does the question, what's it asking me for? It's usually going to be asking me for the vertex or the X intercept, so the solution, and you would solve by factoring, okay? All right, so that was page 27. We are going to jump to page 29, and at the bottom of the page, you're going to see a question that says quadratic word problems. There are other types of quadratic word problems. Today, we're going to be talking about those vertical motion, and this one is an area problem. So quadratic word problems a lot of times involve geometry and involve area problems. Okay, so area of rectangles, area of triangles. So let's look at this first example. A plot of land for sale has a width of x and a length that is 8 feet less than its width. A farmer will only purchase the land if it measures 240 square feet. So the fact that it's saying square feet is telling me that he wants an area of 240 square feet. What value of x will cause the farmer to purchase the land? Okay, so we are trying to find x. Now they told us the width was x, so I'm going to actually draw a picture of this. Okay, I'm just going to draw a rectangle, and I'm going to give one side x. If one side x, it says the other side is 8 less than that, then this side would be x minus 8. Okay, so now it's a rectangle, and we were given the area. So that's my hint that I may need to use the area formula. So the area formula for a rectangle is length times width. All right, so I have my length, I have my width, okay, and I have my area. So I substitute those values into the area formula. So I'm actually going to write 240 equals x times x minus 8. I put it in parentheses. And then I see that this looks very much like one of those special cases that we were solving yesterday. So I'm going to distribute my x. All right, so we get 240 equals x times x is x squared. X times 8 is negative 8x. All right, so I see that it's a quadratic function because the highest exponent is a 2. So I'm going to get the equation set equal to 0 and solve by factoring. So I'm going to come over here. So I'm going to do x squared minus 8x. I'm going to subtract the 240 to the other side, so 240, and that equals 0. All right, so now I have to solve by factoring. So I'm looking for the factors of 240 that add to 8. All right, so let me think about this. I know that I've got 2 and 120. I've got 3 and 80. I've got 4 and 60. Those are really too far away, aren't they? What about, let's see, 12 and 20. And I knew 12 went into it because 3 and 4 went into it. So 12 times 20 is going to give me 240. So I'm going to try those. X and X, 12 and 20. In order for me to get a negative 8, 20 would need to be negative. All right, so now I've got my factors, and that does indeed give me a negative 8. All right, so now I'm going to set each factor equal to 0. So x plus 12 equals 0, and x equals negative 12, and x minus 20 equals 0, so x equals 20. Well, he said that x was the length or the width of the figure, so length or width can never be negative. So I'm going to actually throw that answer out, and my answer is going to be 20. So the value of x that would cause the farmer to purchase the land would be 20 feet wide. Okay? All right, so there's one good example. That's a geometry problem. We're going to look at one more. All right, it says find two consecutive odd integers. All right, so first of all, we know an integer is a whole number, a positive or negative whole number. We talked about that earlier. All right, consecutive means like right next to each other. So 1, 2, 3, those are all consecutive. 1 and 2 are consecutive integers. 2 and 3 are consecutive integers. All right, but then it says consecutive odd integers. So 1 and 3 would be consecutive odd integers. The next consecutive odd integer would be 5, okay? All right, so if I say that the first odd integer, I'm going to let x equal the first odd integer. This is the hard part, guys. The next odd integer would have to be 2 away from it, right? Each one is 2 away from the previous one. So the second odd integer would be x plus 2. Okay. Then it said find two consecutive odd integers, because I got my integers, whose product means multiply, whose product is means equals 99. All right, so we're going to take our two odd integers, x times x plus 2. We're going to set them equal to 99. Okay, and there's another one of those special cases. It's not set equal to 0, so that means I have to distribute. So I get x squared plus 2x equals 99. It is a quadratic equation because the highest exponent is a 2, so I have to get it set equal to 0. So x squared plus 2x minus 99 equals 0. I'm looking for factors of 99 that add to 2. Hopefully you're seeing 9 and 11. So x and 9 and 11. And let's see, I want them to be a positive 2, so that's going to be a positive 11, a negative 9. I set them both equal to 0. So x equals 9 and x equals negative 11. All right, so the first possible odd integer could be 9. If 9 is the first odd integer, the next one would be 11. Okay? All right, so if x is negative 11, so I have two possible answers. If x is a negative 11, the next odd integer would be negative 9. So both of these actually work. So I have two solutions to this quadratic, which there's my two solutions, okay? All right, so I'm going to stop there, and we're going to do a lot more practice with this tomorrow. It was a pretty short video, so you may want to rewatch if there was anything that was confusing to you. And come with questions tomorrow. See you later.